Hello, welcome. Welcome to this Monday Enlightning episode. Thanks so much, everyone who's coming on a different day. I'm so glad you're here. Glenn Renfro's here today. Hi, Glenn. How you doing?
Hey,
I'm I'm here with my friend Jonathan Ivanov. So glad to have you today. Jonathan and I got to hang out a bunch at DevNexus recently. We gave each other COVID, so nothing forms bonds like shared trauma. Welcome so much. Tell us a little bit about you, Jonathan. And I'm using the English pronunciation of your name.
hey, thanks for having me. I'm super excited for being here. And my the English pronunciation of my name is totally fine. I usually go with that in the US because it is simpler. I am from Hungary, so the pronunciation of my name is actually it's interesting because Hungarians are using like not first name last name, but the other direction. So my
Ah,
name is Ivanov Jonatan. That's
ah.
the pronunciation. But it's easier to go with Jonathan for everyone.
So do people call you Yvonne?
No, they call me Jonathan or sorry,
Uh-huh.
Jonathan or Johnny. It's like very close to the pronunciation of Johnny Mitchell.
Oh, nice. I love that. All right, we have lots of friends to say hi to. David Michaels here. Hello. I'm stoked for this too, David. And Aaron's here. Hugs. So's
Hey.
Joy. Hi, Joy. And Salaboy. Hi, Salaboy. Oh, I'm so excited. So, so one thing we bonded about over when we were hanging out at DevNexus is somehow I don't remember now where, but maybe it was you who told me. Somehow I found out that it's scientifically proven that people are more honest after dark. And so you and I started bonding about like people and biases and uh, I guess maybe in a nefarious way how to manipulate people, but I don't think either of us have a mean bone in our body, but more just like how I love knowing that. Here's an example. When I was a server in college, they taught me about this. They taught us all about this thing called the Sullivan nod. And they said when you try to upsell some food, when you say like, "Do you want cheese on your burger?" You do like a you move your head in a way, and that's going to get people to say yes to you. So those kind of tips and tricks about how to get people to do what you want are fascinating to me. Do you remember a couple that you taught me about when we were together at DevNexus?
I am not particularly good at this because there is a huge list, but yeah. So being more honest in the dark, I'm not 100% sure if it is like scientifically proven, but it is definitely observed. So
Observed.
so there is a pattern, and that's my experience as well.
Yeah.
And also we like I believe the whole thing came up with like we talked about the book uh, written by Daniel Kahneman, and its title is Thinking Fast and Slow, and
Thinking
he's a
fast
Nobel
and slow.
Prize. Yes, he's a Nobel Prize winner, scientist, and he wrote this book and explained a lot of biases in it. And I will talk about at least one of them shortly in my talk. So I am not going to
Okay.
talk about that right now. uh,
I love
but
it.
but but there are like a lot of like things how like the brain will basically like go to a false conclusion without us knowing about that. Uh, that's why, for example, like and it is like used a lot, not just like by servers by nodding, which is basically like trying to force or encourage the other party to cope or like copy
Uh-huh.
your behavior. But that's why, for example, if you go to a supermarket, there is also like very nice music. There is never
Yeah.
a clock in the supermarket. You will not
Oh,
find
yeah.
it. Also, like basic food like eggs, milk, bread, that is
Uh-huh.
in the furthest point in the supermarket from the entrance.
Ah, that makes a lot of sense.
Uh, and also like there are a lot of biases that like are basically built into us, into our thinking, into our behavior. Yeah, it's a pretty fun book.
I'd love to ask the chat if there's anything that you've observed or you know about. I guess part of my interest in it too is knowing when I'm being manipulated. So it's not all about just me being the manipulator anyway. But we have hello to some more people. Hello, Mariano. Thanks for coming. And hello, Thomas. So good to see you. I'm really excited to talk about observability, but I understand that you almost went to med school. How did you get into being a software developer and into observability?
Yeah, so the whole thing started in high school,
Yeah.
because in Hungary, in high schools, you need to pick like two subjects that you will learn like deeper. I'm not 100% sure, but maybe it is called a major in the US.
Major, yeah.
Yeah, so
Except
you
we
need
do
to.
majors in college and not high school.
Okay. So you
Mm-hmm.
need to pick like two, because in Hungary, at the end of high school, there is a huge exam, and you need to basically have like a couple of classes that you need to take an exam, like an exit exam, and also
Uh-huh.
you need to take an exit exam from at least one of these majors.
Mm-hmm.
And when I needed to pick my major, as far as I remember, I wanted to pick physics and
Uh-huh.
computer science. Now, that was the first bump on the road, because they told me that, hey, because you are in this class, uh, we are not start a physics major for this, so you cannot choose it. I was like, oh,
Ah,
okay, I like biology as well, so let's do like biology and computer science.
okay.
And I picked those, and
Uh-huh.
that was like the end of the second year. And in the beginning of the third year, you get basically your schedule, your timetable.
Uh-huh. Uh-huh.
And when they like read the timetable, they said, okay, who is biology major? You will have this advanced biology class. And who is on computer science major? You will have this computer science class at the same time. I said,
Oh.
I am not yet able to
Uh-huh.
do that. I
Uh-huh.
cannot be two places at the same time and say, okay, yeah, you need to pick something else. And it was like literature, grammar, like singing and art, and I don't know, and there was chemistry as well. So that's
Uh-huh.
why I was, or yeah, I basically did biology and chemistry major at the end.
Oh,
But when
yeah.
I needed to like go to the university, and
Uh-huh.
I applied, uh, you at the end of high school, you need to get these points, and
Uh-huh.
the exit exam, and basically like go towards the like 4 years. And my university was very, very kind, because they like accepted my biology major. I was able to get those points
Uh-huh.
like through biology to get into the university. And
Okay.
yeah, that was very, very unusual that they did it, but they did. And then when my biology chemistry teacher, she was the one person who taught me like biology and chemistry, and I really, really liked her as a teacher. So she when she heard that like my exit exam from biology was very, very, very good, like
Mm-hmm.
exceptionally good, and I won't go to med school. She
Uh-huh.
just like stand in, and she said to me, Jonathan, you're such an idiot.
Really? Because you wanted to go to med school?
Yes.
Uh-huh.
I was thinking about that as well. So I wanted to be an eye doctor, because
Uh-huh.
I have like the very, very, very weird things with my eye.
Uh-huh.
I am not going to that one now, but yeah, I I was really thinking into going into med school, but get into like computer science school, and that's how I got into software engineering.
But then from eye doctor to observability, it's still about perception or being able to see.
Yes.
That's amazing. So I want to do a quick plug. I got some stickers made. I have some Enlightning stickers. I've been handing them out at the conferences I've been at lately. So if anyone who with a US address wants to DM me their address on Twitter, my Twitter handle's you can see it. I'll mail you a sticker, and then maybe you can tweet it when you get the sticker and stick it somewhere. But anyway, I just thought that would be fun. So I just wanted to say that. Okay, so
Joni, for me.
Save one for you? Yeah, heck yeah. So let's talk about, I'm going to throw you a softball, and then I'm going to get set up behind the lightboard. So I want to know about your job now as a Spring developer and your role within Spring Observability and what you're up to. And then while you talk about that, I'm going to move behind the lightboard.
Cool.
Also, actually, too, in the chat, anyone who's watching, if you have experience with observability or any specific questions about observability, I'd love to hear about that. Okay, go for it.
Go ahead, ask questions.
Yeah.
For that. So yeah, I am a part of the Spring engineering team, and inside of the Spring team, we have this smaller group called the Spring Observability team, and this team basically like consists of 3 people, like Tommy Ludwig, who is the lead of Micrometer, Marcin Szeszczak, who is the lead of Spring Cat Sleuth, and myself. And this year we are working on a new initiative which has the same name as the team, Spring Observability. And this was announced last year on Spring 1 by Jürgen. And
Joni, we already have, can I ask you a question? We have a question in the chat from Gil Snable. What do you mean by observability?
I saw that question, and that will be the first thing that we will talk about.
What's behind the lightboard?
Yes.
Got it.
What is observability and what we usually mean by it? Actually, we will talk about this question like multiple times, I guess, today. So yeah, that is definitely coming.
Excellent, thanks.
So back to Spring Observability. So that was announced by Jürgen last year on Spring 1, and Spring Observability will be a big topic for Spring Framework 6 and Spring Boot 3. And basically, we are doing 2 things in this big effort. One is we are trying to come up with a consolidated API that can cover all of your observability needs, or most of your observability needs. Let me say that the usual ways that you want to know about a system, and we will talk about that as well. We are trying to cover that under like one single API, because right now you at least need to use like 2 or 3. So that's one thing. The other thing is we are trying to use this API to instrument the whole Spring portfolio, because right now instrumentation is all over the place. For example, like if you want to instrument for one thing that is kind of like hard-coded and part of the code base, but if you want to instrument for another thing that lives in a separate project. So we are trying to consolidate all of these and like have the instrumentation under this single API. Not necessarily everywhere, so we are not trying to force it, but where it will make sense, we are trying to do that. So that is basically Spring Observability.
Excellent. So are there any questions about that? Let me see. We have a Fuel Stable also. Thanks for coming. And we have I can finally watch live. Great. Thanks for coming. That's wonderful. I'm almost ready for the start. When I was at the conference at KubeCon, Suzanne is someone I met there, and she had a joke for me. She said, what do you call 2 women at a tech conference? Friends. I thought that was great. All right. I'm ready to learn from you. Where should we start by tackling this big topic? What is observability?
I believe we should start with that simple question. Like
Yeah.
what is observability? Or actually, the question is simple. The answer is not really, I guess.
Yeah, Fuel Snable says I didn't
Yes.
dare to guess.
So I believe it depends who you ask this question from. You can ask Wikipedia because
Mm-hmm.
observability is basically a thing. It comes from math. It is from control theory. So you can definitely read the definition there, which more or less will be very, very close that you want to do in software as well. But observability, or at least to me, is basically like telling us how well we can understand the internals of a system based on the outputs. So basically you need three things. One is a output.
Let me catch up to you. So observability, let me even write observability. That sentence you just said seems very important, so I want to capture that. Observability. Okay, I feel like observability is how well you can understand the internals of a system, right?
Yes.
By examining its outputs.
Exactly.
Okay. Fuel Snable, what do you think of that answer? Or anyone really? This is dragging. By examining its outputs. Okay, so you were about to say there are three things.
Yes, and basically those three things are hidden inside of this sentence because if like you need some kind of output that you already highlighted, and this output should provide you some like meaningful information. That is important. So it is not just an output; it needs to be meaningful.
And
it needs to tell something to you about the internals.
And you're saying an output, but is it? It sounds like it could be multiple outputs too. Is it
yes.
a singular or plural?
No,
so you
there
need
are
plural.
Yes, there are many of them.
Okay, so you need meaningful outputs.
Yes.
And the meaningful part is important. What's an example of an output that's not meaningful?
Like, I don't know, duplicates, for example,
Okay.
that is not necessarily meaningful, or something that just tells you like, I don't know, some noise, like some garbage data. For example, like logging, you can see this all the time. It's not necessarily like makes something more observable if it is not meaningful for you. Okay. But there are a lot of like things that you would think it's not meaningful in the first place. I will talk about these as well. There are a lot of them, but they are very useful. And we have questions also.
Wait,
like,
hello, hi. Thank you so much for coming. And here's I just clicked the wrong thing on my iPad. Oh goodness. Okay, Fuel Snable has a question. Does logs and metrics count as increasing observability?
Yes, definitely. They are components that can make your system more observable easily. Like they are. We will talk about this as well.
Okay.
They are important. They are very important.
And then Fuel Snable's asking about heat and noise, but I don't really in this context.
I believe those are questions for your question about like what is not meaningful.
Okay, got it. Their answers: noise and heat. Got you. And we have more questions. Do you count? Can you hear me?
Yes, we can.
Okay. Do you
Or
count
at least
health
I can.
checks? Good. Do you count health checks as part of observability? Aaron says, I do.
Yes, definitely. Like that is very very like important component. And thank you for asking this because I am planning to talk about this as well.
Excellent. And Nick is here. He says, hello, people. And then Field Sneeble says, then I probably have opinions about observability. Can't wait to hear them.
Everyone has. That is like today's like huge like buzzword that very very like fragmenting the community. Everyone has its own or their own opinion about it.
Yeah, I had no idea it was such a controversial topic. I thought it was going to be more straightforward. I can't wait to let's fight, you guys. All right.
Okay,
so 3 things. We got the first one. You need meaningful outputs.
Actually, that covers too. Like it needs to be like meaningful information and given by an output, and it needs to give like some information about what is going inside of your system. So a meaningful output about the internals. That's the 3 things.
Oh, okay. So you said there were. Okay, here's what we're gonna do.
So basically, the sentence already contains that.
It almost. I think it will contain it if we say by examining its meaningful outputs. And then the 3. Now we have internals and meaningful and outputs are our 3 things. Yeah?
Yep.
Cool. Excellent.
So this has a couple of like consequences. And I don't think we need to capture this, but let me just run through them like very quickly, because this means a couple of things. For example, you should be able, if you have like an observable system, then that should mean, because of this, that you should be able to ask like arbitrary questions about your system, because you have all of those outputs that gives you the answers for these questions. And I believe the hard thing in it, there is a twist or the trick here, is that you should be able to answer arbitrary questions, but without knowing ahead what you want to ask.
What's an example of an arbitrary question?
So it is basically like any question that can like come to your mind during like troubleshooting or debugging or like going down into like a rabbit hole of an issue. Basically, this means that any questions, like if you want to examine like a dimension or multiple dimensions of a software system, and this can be like multiple applications like talking to each other, you should be able to ask those questions, and you should be able to get some good answers for those questions.
Nice.
And we know like a lot of these questions in advance, like, hey, like how many arrows do I have?
How many errors do I have? Yeah.
Or like, hey, what is the maximum latency right now, or in this like last 5 minutes of the system? These are very very common questions. People are knowing this. People will basically like prepare for this and prepare their system for this. But there are a lot of other questions, and I will totally give you examples for these as well, that you might not know you will ever need, but there will be this one time when something happens and it will save your life. That is basically what observability all about.
So you don't know what you don't know, and you're trying to make sure, that when you do figure out what you don't know, you're able to find it.
Exactly, and this is one of the cognitive biases that we talked about earlier, and this is called the Dunningkruger effect.
The Dunningkruger effect.
Yes, that you don't know what you don't know, and the Dunning-Kruger effect, basically, it's a hypothetical cognitive bias. As far as I know, it was never proven, but it was observed. So what it says is that people's they have a tendency of like weighing their own ability in something like a little bit more than it is. So yeah, being able to ask like arbitrary question, being able to troubleshoot problems with no prior knowledge, that totally belongs to observability.
Excellent. We have a lot of activity in the chat right now. So
yeah, let's see that.
Yeah, so Fuel Stable is unique that his opinions are objective truths. It's a gift.
And this is also like falls under the umbrella of the Dunningkruger Effect.
So true. All right, Java Grunt says, raise your hand if you've ever had someone in ops say, don't worry about monitoring, we will take care of it.
And then Java said, like, hey, this will never ever happen. And then it happened. This happened to me multiple times. And somebody said, hey, this will never ever happen. And
Popsigot raises both hands and a foot. And what is our most costly service would be a question you would want to ask of your system. It sounds like Fuel Stable says. Fuel Stable says, I think one benefit of DevOps culture is that it can give better observability as developers feel motivated to add things and improve ops. Yes. Do you agree with that?
This is very, very important, I guess, because I believe observability, I'm not 100% sure that as of today, but it used to be like this. It was like in the same bucket as security. Deep talked about this, 2 episodes before or 1. And basically, people are basically throwing observability and security into this bucket. Put that bucket into the darkest corner of the office where there is nothing, just spider webs, and forget about it. This I can see this changing nowadays, but this is the starting point where we are at.
Fuel Stable saying something similar. Otherwise, metrics and logs are just tickets from the complaining operations guys or complaining operations girls. Thank you very much. And then we had a question here. If we utilize observability, is it safe to say there is no need to utilize Prometheus and Grafana? That's a question. That's what is monitoring versus what is observability, right?
That is a way harder question than it seems, and I guess it depends who you ask. I think then it is safe that you can use Prometheus and Grafana to implement observability. Those are just like one piece of puzzle in the huge picture. But you can totally use them. Like they are not bad. And I think then, as of today, most of the people will use either these tools or something very, very similar.
So you use Prometheus and Grafana in addition to other observability solutions, not instead of. Yes. And then Fuel Stable says, I would think of Prometheus and Grafana as something that gives OBS. What's OBS? Observability? Just another, yeah.
If you think about the original like question or like the sentence that you put up, like Prometheus and Grafana, they can totally give you meaningful information, meaningful output about the internals of the system. If this holds true, yes, I think that is one piece of the big observability puzzle. It totally belongs there. Again, if you ask other people, maybe they say no, hell no, get out. But I can live with that definition and with that way of thinking about this.
Excellent. So what's next?
Let's talk about why do we need it.
Why do we need it?
We kind of answered the question of what is it from a vague or from a high perspective. But why do we need it? I believe that is also a very, very important question.
Why do we need it?
And I believe the single word answer for this question could be because of complexity.
Oh, that makes sense. And when we say
There are more. I will mention way more things. Why do we need this? But I believe like complexity is the biggest driver as of today.
And is it worth saying that we're making an assumption here that we're talking about a distributed system? Is that true?
Not necessarily. So
Oh.
a system doesn't need to be distributed in order to
Uh-huh.
be like very complex. So distributed systems, yes, they don't help in this area. They will make things more complicated and more complex.
Yeah.
But like if you have like a big distributed system, it's like, I don't know, like hundreds of services or components. If
Uh-huh.
those if you are building the same application but as a monolith, that
Uh-huh.
will still have those components that need to talk to each other. Like
Okay.
you will be saved a little bit from the fallacies of the distributed system. You will not have a network and a couple of things, but its complexity still can be huge.
Okay.
So even if you are building a monolith, there will be things that will not be needed for you, but you still need observability if you want to look into your application.
Excellent. We have lots of thoughts from Fuel Sneebel. Fuel Sneebel says they've been working to add observability to their system where before there was very little. After many months, they now know about most problems before the customer calls support. That's cool. So
That's
here's
the whole
Fuel
point.
Sneebel's. Yes. That's the whole point you said?
Yes.
Yeah.
So being able to know about that, hey, we have an issue and this is the issue and this is why it happened before it will be like widespread and before customers will be impacted.
Absolutely. There's a lot of value in that. So here's Fuel Sneebel's controversial thoughts. Fuel Sneebel encourages devs to work to debug using logs and metrics and not using the debugger. The idea is that logs and metrics is what we have to understand our production system.
Exactly.
You're in agreement?
Yes. This is a very valid point. And also, like there is an opposite way of thinking about this, because once you will add like meaningful, for example, metrics and logs, then it happens a lot of times. I have seen this in real life, that once people added these, they started realizing that, hey, we have a bug here, we have an issue there, and so on.
Uh-huh.
I believe Erin can talk about this next time. When will that be? July 26th? She will talk about metrics?
June 16. Yeah, Erin
Okay.
Schneebel is coming on in a couple weeks and she's going to talk about metrics. Erin, if you're here, go ahead and plug your show a bit. But Erin said an upcoming guest. So Fuel Sneebel says many devs love the debugger, so it's tough to get traction for his idea, but he thinks it'll promote better observability.
I think I have like a very good analogy to this.
Okay.
I'm not sure which book I read this, but one of the books like mentioned that, hey, observability is like sending rovers to Mars.
Sending rovers to Mars?
Yes. Because after you launch them,
Uh-huh.
they are gone. You cannot really attach a debugger in production, or at least you should not. Or in a sense of like like what we mean as a debugger in your IDE. Once they are launched, once your application goes to production, it's gone. It's shipped, and you need to get all of that information that you need from those things that you built into previously. So
interesting.
that's what
I love that.
observability is trying to give you. That, hey, I will build this mechanism inside of my applications. And because of this, the applications will be able to give me like outputs that I can look at. But yeah, you cannot really debug them in the sense of like the classic way of debugging in your IDE.
Yeah. It sounds like it's not mutually exclusive too.
Oh no,
But
locally it's a totally fair point, but
yeah.
it's a good exercise to try to understand what is happening without the debugger.
Fuel Single says finding metrics from far back can be important to solve a problem. How did the traffic at the same time look yesterday, last week, last month, last year? That's
Yep.
And then Aaron's chiming in. We also have logs, metrics, and events, collected data that can be sliced, diced, analyzed, digested later to answer the unknown unknowns. But you can only look at what you have.
Yep. Okay, so let's dig a little bit deeper. Like, why do we need this? So one thing is totally like complexity, because this is like one of the biggest drivers, I think, today, because we used to have these like not as complicated like software systems. Right now in the cloud era, in the cloud environments, we have like enormous complexity boom. And we need to face these unknown unknowns. And we might not know a lot of questions because the cloud will hide this from us. So where are apps like running? How many instances do we have? In what environments or what versions? We cannot really like debug or modify them. And because of this like big basically on this scale, because of this huge complexity as well, something is basically always broken if you have a big system.
Oh.
And I really encourage everyone to go to Wikipedia and search for fallacies of distributed computing, which will give you like a list. If you are building a distributed system, read that list, because it can save you some time in the future if you think about these elements as of today.
So what's an example of a fallacy of distributed computing that would be on that list?
For example, the network is not homogeneous. That's one fallacy that people are usually. It can be a cognitive bias for software, which means that network throughput and latency, it can vary based on the direction of the communication or based on the location.
Okay.
I have totally seen this in real life, that like sending a request was way faster than getting the response back. And it wasn't because the response was huge and the request was small. They were like ballpark the same. But for some reason, some router thought that it is or I don't know what happened like on the network wise, but it was like significantly slower receiving the response than sending the request. If you, for example, think about this, like when will this happen? Practically never will happen. But once it will, how will you know about that this is making your system slow? That it is fast the way there and it is slow back. It's kind of like there are a couple of like mind-blowing things there that you need to think about and build these mechanisms into your system, and that's what observability should give you. But let's move on from like complexity to chaos. And so that is another thing that we will need. So why we need observability? Because like environments as of today, especially in the cloud, can be chaotic. And when I say chaos or chaotic here, I really mean like a chaos theory from math, which says that a small change of a system or like a small change in the initial like state of a system can result in large differences in later states. So chaos really means that, for example, in software, that you turn a knob here a little bit, and somewhere else later services can go down. And you cannot really predict. If you think about the butterfly effect, it is exactly this. Or I'm not sure if you have seen like a double pendulum. That is totally like a chaotic system. If you like move the pendulum a little bit initially, it will like do like a way different like set of movements. So yeah, chaos is also I guess a driver for observability as of today.
Excellent. And so if I want to put a little sub note on complexity, if you want to like sum it up in like a quick phrase, what would you put there?
About complexity, I would say like I would either like put like Death Star architecture there, which is not a sum up, but it is like a good like indicator of complexity. I would just like summarize it as like facing unknown unknowns.
Okay. Yeah, I like that. And we have lots of activity. Java Grunt likes the sending of rover to Mars point. Putting an app into production is like sending a rover to Mars. That's great. Feel Seamless says to me, it's more mind blowing that things work at all. I totally relate to that thought. Feel Seamless says a small load increase can cause one service to fail, then another fails, which creates more load, then other services crash, and so on.
Yes, these cascading errors are totally a thing, and yeah, falls into this category.
And then Death Star architecture, great summary for complexity, which came from Java Grunt. All right.
And just like another thought about these unknown unknowns, so this is where like the Dunningkruger effect shines, because we cannot know everything, and we need to deal with them. And I have stories about like a lot of them, like people saying that, hey, this should be impossible, or hey, this will never happen, until that one time when it will. And it did. I literally seen this in like stack traces, in logs, in error messages, that hey, this should never happen. And I was like, what are you talking about? I am just looking at it.
It seems like by the time you get to the point of naming it, it almost certainly will happen, right?
And I believe maybe the third thing I would put here is, to me, it's hard to name it. I usually call it relativity, but that's not the word I would like to use. But the word I would like to use is not very known, because it is a German word. And the word is Umwelt. And it's spelled Umwelt. And sorry, right? L. So not R,
E-L-T?
but ELT, yes.
Umwelt.
Yes, and instead of this, I usually like say relativity to people, because Umwelt is basically the idea that because our senses pick up on different things and pick up different information, we actually live in very, very different worlds.
Ah, yes.
And there is, or let me say was, a very, very good like example for this. I'm not 100% sure if you know XKCD.
Yeah, that comic.
Yes, it's a web comic. It's a genius web comic. And
Mm-hmm.
there was a episode about this. This was this title, Umwelt. And
Mm-hmm.
this particular episode, I don't think it is available anymore. I believe it's broken now. But what it did is that the comic itself that you saw, it changed, and it
Mm-hmm.
did not change over time, and it did not change for everyone. But where it changed, it was changing based on the browser that you are
Oh.
using, your
Uh-huh.
resolution, your
Intentionally?
yes, your location,
Okay.
and
Uh-huh.
your referrer. So basically, what comic you did see on your
Uh-huh.
screen, it
Uh-huh.
depends on where do you live, where you came from
Wow.
to that page, which
Uh-huh.
browser you use, and what resolution. And
Okay.
there were like way different web comics, and I believe somewhere on Wikipedia, or I don't know, someplace on the internet, people
Amazing.
actually try to like trace this down. And
Uh-huh.
there is a map of like, hey, if you are using like this, then you will see this. And there are all of
Wow.
those. So basically the same thing. So this basically means like relativity or Umwelt. This can mean that the same thing can be perceived differently by different observers. And an example for this in software could be that for you, everything can be okay. If
Uh-huh.
you look on your software system or your application, everything is green, everything works,
Mm-hmm.
but at the same time, everything can be broken for your users.
So you're talking about when you first said this, I was thinking of it more subjectively, like people's brains perceive different things differently based on their life experience. But you're talking about
Definitely.
it more from a systems, like if you use this browser or this, which way do you
I
mean? Yeah,
both, actually
both,
both, because
both.
like one thing is like a more like objective, or like the bigger picture when you talk about your system, but when you will like debug your system or look into it,
Uh-huh.
one
Ah,
signal that is there, people can
uh-huh.
have different opinions about that.
Yeah. Okay. That makes so much
And
sense. I love.
also it can happen that the same people will see like different signals about the same
Yeah.
thing at the same time.
Yeah. Amazing. Yeah. So we have lots of every 72-hour incident starts with this can't possibly go wrong. I
Exactly.
remember fondly, Feel Stable says, I remember fondly when I just changed a tag of a service which caused the entire front service to fail, causing data loss. And a tag change generally is considered very safe. Thanks for that context. The incident review results were illuminating. And so, related to what you said about the KXCD comic, Google Maps shows different results depending on where the observer lives. There are areas that are disputed to give the observer what they want to see. And then we have a Mark, hello, welcome. There's a radioactive water on the floor of the reactive control room, but the lights on the panel are all green. Ah, yes. That's a
I like this example. Yes.
that's a great example.
Uh, and I would throw in like two more things.
Okay.
Why do we need observability? And one
Mm-hmm.
thing would be if you want to improve something like this, I would say like in one word or two words that you will need this because of continuous improvements. If you want
Continuous
to improve,
improvements.
yes, if you want to improve something, you need to be able to measure it. That is basically it.
Who doesn't want to improve something, right? Continuous improvements. If you want to, let's do this. So it's these are all just reasons to measure. Also, is that a good way to talk about why do we need observability? Why do you need to measure things? Is that a similar question?
I think so, because if you want to like make something observable, you need to measure things.
Mm-hmm.
It basically like measuring something is like getting meaningful information, a meaningful output about something.
All right. Excellent.
And I would throw in a fourth thing, and I'm not sure how to capture this, but observability can like open the door for other advanced capabilities.
Okay.
And these capabilities can be like, for example, chaos engineering, which is
Okay.
basically the act of like injecting failures into your system intentionally. Now, if you think about it, that hey, I want to inject failures into my systems, doing this without observability, yeah, don't go there. You need to know what is happening exactly if you want to make bad things. If you want to torture your system, at least like measure it. Be able to get this information first.
Yes, at least learn from it if you're going to put yourself through that kind of stress.
Uh,
Did I capture this? Did I capture this correctly? It can open the door to advanced systems. I feel
yes,
like
yes,
okay.
yes. That's very good. Also, with observability, you can do anomaly detection, which basically can tell you if something is out of trend or fishy, just based on the sheer data that you had in the past or will have in the or have right now.
What was what you just said?
So first was chaos engineering. The second one was anomaly detection.
Anomaly detection. Excellent. And we have some comments and questions. Fuel Stable says, if I do an improvement, it's an admission that my previous work was not perfect. Can't have that. That's why you wouldn't want to improve. And then Glenn has a question. Can we observe ephemeral applications, think Kubernetes jobs, as well as long-running processes, specifically beyond log monitoring?
Yes,
It's a
you
great
can
question.
definitely. So beyond logs, you can also like get like metrics about these short running or long running processes. It's easier for long running things because you will have more data.
Mm-hmm.
But you can do the same thing. It will be a little bit more challenging. And you can also like track these events, what is going on in these short running processes the same way. So there will be things that you might need to do a little bit differently, but at the end of the day, you need to get that information.
Excellent.
Okay.
We have a Glenn makes Java Grunt think about the overlaps of telemetry and observability. What's telemetry? I don't think I've heard it before, but I don't think I have a solid meaning in my
Telemetry is
mind.
basically like measuring something and recording those values over time.
Okay.
Or at least that means to me. Maybe somebody can give you a better explanation in the chat. Yeah, so telemetry is all about like producing a meaningful output, which will give you more data about the internals. So definitely belongs to observability.
So you need telemetry for those inputs that help you put together observability.
Yes.
Got it. Or
Definitely.
outputs, I suppose.
Yes.
Excellent. And then Java Grunt says push versus pull for observability, perhaps. Are you talking about telemetry with that comment, Java Grunt?
I believe he might talk about like pushing or pulling metrics, because once you like start collecting metrics and you want to record them, then you can basically like send those metrics to a backend. That's basically pushing them. Or the backend can query you that, hey, give me your metrics right now.
Okay.
I guess I'm not 100% sure if that's what it's relates to, but I'm guessing here.
Aaron says telemetry is in the situation, collection of measurements or other data at remote points, and their automatic transition to receiving equipment to telecommunication for monitoring. So that's similar to what you said. Yeah. And then Java explains his comment, telemetry pushing metrics versus pulling metrics via the metrics endpoint. Yes. Okay, great. Thank you, Java. So I'm a little concerned that I'm taking up too much space. Do you feel like I'll do my best, but yeah.
We can do it.
Okay.
Just let's put like a couple of more things for these more advanced capabilities, and then we can move to and let's talk about like some more like exact things about observability. So other like advanced capabilities can be like feature flagging, which is basically turning features on and off based on schedule or manually.
Okay, feature flagging.
Also A/B testing, which is kind of related. A/B testing basically can tell you that, hey, is it better if I do this or is it better if I do that? For example, if a button is blue, will more people click on it if it would be green? And people are doing, like big companies are doing these experiments all the time, and you will need observability in order to tell that, hey, if something is better or not. You can also do auto-tuning.
Speaking of manipulating people, auto-tuning?
Yes. Auto-tuning is basically the act of like changing parameters runtime as your application is running and checking if that is like making the application performing better. It is kind of like A/B testing, but not on your users, but on your running system.
Yeah.
Performance-wise, yes. And also you can implement adaptive applications using observability. Adaptive applications. Adaptive apps. Yeah, so what they do, they are growing and shrinking, and they are like defending themselves, automatically fail over, recover from the error based on the environment. And they should do this, like this whole thing automatically.
Excellent. We have some comments. This is so good, says Java Grunt. Thank you, Java Grunt. Mark says, are there solutions for observability which don't compromise the security of the system? The more exposed state, the larger the attack surface.
Yes, I don't think that this is like a compromise, but yes, it is definitely a increased surface, because like the point of observability is giving more information about what is happening inside. And if people who will need this information wants to like hack your system or like breach it, they will get that too if you provide to them. But all of those things that we talked so far and we will talk today, everything can be basically like secured. So I don't see it as a trade-off. I usually think that when you provide more information, you should not do it like publicly about your system. Maybe there are some things that you want to, but you need to secure them. But once you secure them, what is the difference between like people will have like access to your system or people will have access to the output of your system? Those are like both like equally important, and you need to secure both.
That makes a lot of sense. So Fuel Stable says, I don't think security is compromised. I think it rather helps you can identify weird stuff. That's a good point. Fuel Stable says, however, privacy can be something you need to consider in the logging, as long as it's super easy to log sensitive data by mistake.
Oh, yes. Also, I'm not 100% sure that this is the same situation as of today, but there are like loggers in like, I guess it's the most popular like servlet container in the Java world. If you change the log level for one of those loggers to, I guess, like trace or debug, it will basically log out the whole traffic with the if we are sending passwords, Those will be logged out. If you are
Okay.
sending SSN, that will be logged out. So that is a good exercise to basically like secure these and saying that, hey, if I know that this will provide those outputs, I don't want to, never ever. There is no such situation when I need the password of the user. So I am saying that, hey, no, that's not allowed. But yeah, these things can happen accidentally. So that's why you need to secure them. But after you did that, you can be safe. It can be tricky though.
So then back to the question, are there solutions for that particularly? If it's tricky, it can be done, but it's tricky.
So most of those solutions that I am going to talk about today, they all have this security mindset built into. So you basically need to turn them on.
Right on.
So let's move to the big picture.
Okay.
Like one level deeper, and I would like to talk about so people are calling this the 3 pillars of observability. I don't really want this name.
Okay.
Or I don't really like this name because it basically suggests that these 3 pillars are the solution. And if you do them, you are good. This is the only solution, and this is, you don't need anything else. This is not true. You can basically, so the 3 pillars, let me say that, the so-called 3 pillars are logging, metrics, and distributed tracing. And that's what I want to talk about. And another thing I usually call like non-conventional components of observability. So these 4 things in the rest of the time that we have. But I don't like the name of 3 pillars because of this. It is not. Yeah, just go ahead. Sorry.
So I want to give this section a title. I could title it "The 3 Pillars of Observability" with an asterisk, and Joni doesn't like this. Or we could call it "The 4 Pillars of Observability." The fourth being
that's equally bad because like right now we don't really. So basically, like these logging metrics and distributed tracing, which are the 3 pillars or the so-called 3 pillars, they are basically just the dimensions of the information that you can get out. And you can basically get out these dimensions only by using logging, if you will. You don't necessarily need the other 2.
Tracing.
But if you have like, because you can push all of these data into logs. Don't do that. I am not recommending it. But you can. Like if you have a very small system, for example, it only runs on localhost, or you only have like one user, then you can totally make it observable by having these dimensions of logging metrics and distributed tracing. I will tell about these like deeper a little bit. Also, like there are other people who are saying that, hey, this is garbage, don't do them. So you just need to emit events. And basically that is something that we are trying to do in the Spring observability effort. We are not saying that, hey, this is how you can emit your metrics, or this is how you can record your like spans for distributed tracing. We are saying that, hey, you have an event in your system that happened, and we are recording it. And how will you basically like present it? In what format or what dimensions will you like get out from this event? That's up to you. We can give you like these basic like dimensions of logging metrics and distributed tracing. We will give you. But if you have a better idea, just go ahead. There is a very, very vocal like person in the observability about this, Charity Majors. She's really vocal about this, and I can relate to what she's saying a lot of times, that pillars of observability is basically a little bit misleading because that might not be the solution.
So do we call it the so-called three pillars of observability with the asterisk?
Let's
Like you can shape it however you want with events.
let's just put up like logging metrics and distributed tracing and
With
this
with no
non-conventional
comment.
stuff. And yeah,
Okay.
and people will be able to because I usually like want to talk about these because the three pillar is, in my opinion, might be a little bit misleading, but right now this is the most popular solution that we have.
Okay. So logging first, and we'll just for now, and then I'll get metrics and
Yeah,
tracing
so
up as we
let
talk
me
about
give
them.
like a short overview about these three, and after that we can add a little bit more things.
Okay.
If you can, for example, like divide into like 4 quadrants the space that we have, then I believe that will be fine.
Okay.
For the rest of.
I'm wondering where my face can fit in, but yeah, I'll figure it out. So logging, metrics, tracing, right? And then we'll put the little bit you want to say about the three of them together here. Then I'll figure this out.
Yeah. So all three is basically meant for answering a question. And the question for logging is basically like what happened. And logging is trying to answer this what happened question by emitting events that you can easily read. It is humanly readable and you can easily like grab it. You don't do it in production, but that's the point.
So for all three of them have the question what happened, right? And then they have different ways of figuring out what happened.
So you can use these, but all of these has like a focus area. So I will tell the other questions like shortly, and maybe that will be better. But I can say or I can see why this can be confusing. That all of these can answer the question of what happened in certain situations. But logging is meant to answer that question about separate events. Let me put it that way.
Okay.
So metrics, on the other hand, they are trying to answer the question of what is the context about these events. So something happened and you want to know the context. And I will give you examples for this later after we captured these three questions.
Okay.
And metrics is doing this, like answering the question by measuring and combining the data. So metrics are basically like aggregatable. You can identify trends using it or using them. But that's the overall question, I guess. That's what is the context.
So logging is what happened, and you meant to answer that about separate events. Wow. And then metrics, what is the context? It measures and combines the data and figures out trends. And tracing, what's the question?
For tracing, I guess the question, or I think the question is why something happened.
Why? Cool. And then how does tracing figure out why?
And tracing is doing this by recording events with causal ordering. So basically, it can identify calls across applications or across these events.
So recording events with codes?
No,
Say that again.
causal, like causality.
Cause, got it. Yeah.
Cause, sorry.
No, it's my bad. CRD recording causes of events, right?
Mhm.
Recording. Cool. Love it.
Yeah.
We have a lot of comments from Aaron. Aaron says, health is a service alive, not a zombie. Is that something that all three of these are meant to figure out?
No, that will be the fourth thing I want to talk about. That will be the non-conventional stuff, because health checks are usually not fitting into any of these. That is basically the fourth group of me, which is very, very important to me, because people are usually like neglecting it. But I believe that's the most fun. But we will talk about that as well.
Okay, so also Aaron says metrics, statistics. How many times did X happen? Logs. What happened when X was called? The details. And tracing. What is the broader cross-service context for X being called?
Basically, these are like the gist of this, but let me give you examples for all three, like the question and the answer for those. So let's go with like a latency example. So let's say that you have a latency problem, or maybe not. So you have some latency situation in your application. So logging can tell you what happened. Is basically like, hey, processing of this one request like took like 140 milliseconds. But is this bad?
Yeah.
Or is this good? What is the context? We have no idea.
Okay.
That's where metrics can like answer the question of like, what is the context? And metrics can say that, hey, like for example, 99.999% of the requests were faster than 140 milliseconds. And the max, by the way, it was 150. So by this, you can say that, hey, this is quite bad. This is definitely not good. But why was this slow? We still not know. So that's where distributed tracing can tell you. It can give you, for example, a topology of your code. And you will see that, hey, service A called service B called a database. And let's say for the sake of this example that everything was fine, the network was okay, the services were okay, but the database was slow. So it can tell you that, hey, this happened, this is the blast radius, is it good or bad? And this is why.
Because you're seeing the whole life cycle of the request in there,
of the call, yes.
Of the call.
And sometimes like distributed tracing can go even deeper, and it can say that, hey, I am telling you not just the database was slow, but it was slow because of whatever reason, because somebody requested a lot of data, or because, I don't know, all three of these can answer like each other's question a little bit in some sense. For example, metrics can say that if you are, for example, collecting metrics about your database, it can tell you that, hey, there is this other process that is eating all of your CPU, and that's why your database is slow. So they can totally answer this question that why something happened, but each of them has like a main focus area.
That makes so much sense.
Let me give you let's answer the question in the chat first.
Okay, yeah. Java Grunt says, what was the state of things at this time?
Yeah, that is definitely like a question this can answer.
All three of these together can answer that. What is the state at this time?
It depends. Like what dimensions do you want to know?
Yeah.
But yes, they should be able to. And let me give you another example for this, which like if the previous one was through latency, and this second one is through an error. So let's say that an error happened in your system, and the logs can tell you that, hey, the processing of this request failed. And here is the stack trace, which can tell you what happened. Maybe it can tell you why happen, but it will not really be able to tell you that, hey, is this bad?
Mm-hmm.
Or yeah, it failed, so it's bad. But how bad is it? It will not be able to answer like how many of them failed. We don't know what is the context. So metrics can tell you that, for example, hey, the error rate was like 0.0001 per second, and we only had like 2 errors in the last 5 minutes. So in that case, it's not bad, but we don't know why it happened. Maybe logs will be able to tell that as well, but distributed tracing can or should be definitely able to tell that. It can, like, again, give you this topology of the call, who called who, and it can say that, hey, everything was okay, except, for example, the database call failed. And sometimes it can tell you that, hey, the database call failed because of an invalid input, which was not validated, and it the database caught it.
I'm trying to capture one of your examples because they're very helpful. Says, is this good? Is this bad? So logging says what? Like a call took X amount of time. Metric says, is this bad? So it's identifying a trend. So and then tracing will tell you why.
Mm-hmm.
So here's a question then. If you only had tracing and not the other two, you would be able to see that the database was slowing something down, right?
So tracing can definitely, so they have some overlaps. And yes, if you look into tracing, then you will be in this example, maybe you will be able to see that, hey, what happened. Not necessarily though. Like in not every case. In this case, yes,
okay.
You will be. But in some cases, you might not. But again, like as I said, you should be able to like have all of these 3, for example, like crammed into logging. You can just publish your you can aggregate your data, and you can emit like log events about this, or you can have this causal ordering, and you do the same thing what you normally do with distributed tracing, but push everything to logs. I'm not saying you should do it, but in that case, logging will answer all 3 of these questions. Or you can generate metrics based on your tracing data or based on your logs. So these can have some some common areas, and also you should be able to like go and connect these dimensions.
But getting back to what you said before, it's easy to take something we know and then apply it to this. But what we want to do is be able to use this to figure out what we don't even know we don't know.
Yes.
So we're going to need all 3 of these because we don't know what we're going to need to figure out what problems we don't know what we have yet.
Basically, yes.
Cool.
So let's quickly capture these like logging metrics and tracing, because we have only 40 minutes, right?
Yes, we have a hard stop at. Yeah.
Okay, so let's speed up this a little bit. So
we're just having so much fun.
I am not going to dig deeper than to logging metrics and distributed tracing in this case, but let's just capture like a few things about them. So for logging, let's talk about the different type of logs that you can have, because sometimes people like what they are thinking about logging when they when they think about logging is actually application logs.
Mm-hmm.
And application logs is basically the common, the classic, log events that usually you can see in your applications. These are these debug info for error, whatever events with stack traces. But there are other things as well. For example, payload logs. Payload logs is basically the raw request and response pairs that you can have, and they can help a lot. What you need to be careful though is not revealing secrets in your payload logs, because they can totally contain those, or PII if you are like storing this in a system where people has access to these logs who should not be able to access PII information.
Okay.
And I am coming from the Java world, so another type of logs which is available on the JVM is the garbage collection logs, or the garbage collector logs. So GC logs, they are capturing the GC events. And they can help you a lot if you are doing like GC fine-tuning or the GC like debugging or troubleshooting. And I believe the fourth one I want to mention here is access logs. And access logs are usually like logs from the underlying HTTP server. They are a little bit, or they have some data that is similar that you can get from the payload logs, but these logs are like much more like shorter or simpler. And the underlying HTTP servers, they are giving this to you out of the box. You don't really need to do anything, just like turn the feature on. Okay, so let's talk a little bit about what Spring has to offer in this domain. Because if you want like application logs, Spring Boot is coming pre-configured using SLF4J, which is like a simple API. It stands for simple looking facade for Java, and also it comes pre-configured with Logback. I mean Spring Boot, not SLF4J. And Logback is basically a modern logging library. So application logs, Spring Boot out of the box uses SLF4J and Logback, and that's how you can implement those. If you want payload logs, then Spring Boot doesn't have an out of the box solution for that, but there is a project called Logbook. And Logbook is basically like a project which has a Spring Boot starter, so it auto configures everything for you, and it will give you payload logs. GC logs, yes. GC logs, that's just the JVM functionality. You don't need to do anything, you just run on the JVM. And if you want access logs, then it is basically like your underlying servlet container. In case of Spring Boot, we have a feature flag that you can like turn on and off, and it will let the HTTP server know that hey, you should emit access logs.
So the thing I'm hearing or wrapping my head around now is that observability has been well discussed and well defined, but like you are putting together your own solution for how you want to capture all of the different types of logs. There's not like
This is how like these are the offerings that like Spring Boot will give you. If you are using Spring Boot and you want observability, these are basically the projects that you can use, or these are the capabilities that already built in for you.
Okay. I guess I'm just surprised. I know so little, but like I guess I'm just surprised how handmade this feels. Or instead of it being like here's an observability platform and it plugs into these things for you. Or yeah.
That doesn't really exist as of today. So you
Okay.
need to like stitch these basically together.
Right on.
And so once you put these projects together, you will be able to have some like connecting them. I will talk about that as well, because once you
Okay.
add, for example, distributed tracing, that will that can basically modify your logs, and it can like put extra information into that, so that you can
Okay.
basically stitch together. If you have a log event, you will be able to tell about that log event, or track it down in your distributed tracing solution.
All right. We got to move along a little bit quickly.
Okay, so let's go to metrics then, and
Okay.
just very quickly, because again, Erin will talk about this next time.
Yes.
So metrics is basically about time series data.
Okay.
And time series data is basically data that can change over time. And that's the whole thing from the very high perspective. And you can use this for identifying, I don't know, like trends.
And we talked about that over here too.
Yep.
So, can you give me like a concrete example of what this looks like? What you're actually collecting here?
So you can collect a lot of things, but if I go back to my previous like 2 examples, like latency or errors, for the latency case, for example, you can capture what is the like maximum latency in this, like, I don't know, 1 minute or 5 minutes,
Okay.
and you can basically draw this in time. Or if I don't want to talk about software, for example, capturing the room temperature and putting the data points of the current temperature over time and saving them. Or in the error scenario, in my previous example, basically like how many error happened in this time range or in this time window, so that you can see the trends, you can see the context, and you can visualize this. You can definitely use this for visualization, also for alerting and for anomaly detection.
So, so how do I capture that last part? Just like
we can
what
just
it's
say
used
that
for?
like used to identify trends, used to anomaly detection. Yeah.
And what was the other one you said? Errors, maybe?
Alerting, like alerts.
Alerts. Oh, Fuel Stable has a lot to say. Hello, Fuel Stable. So have we talked about the importance of a good log aggregator? That's actually an interesting angle. Good equals fast and good search options. So Datadog, while expensive, has many cool tools to analyze time series, anomaly detection, and so on. So anomaly detection is part of a log aggregator, or when the logs are aggregated, that's when you start looking, that's when it goes into metrics, because you'll see a trend.
I would say it is metrics, but you can generate metrics using the logs. So anomaly detection is naturally for metrics, because you need a trend, you need some history to be able to tell that, hey, this is out of trend.
That makes sense. Fuel Stable says, for example, I use metrics to capture numbers of items processed, numbers ignored, numbers failed. Then I have dashboards that give me real-time insight into the health of my system. So for a concrete example, I added metrics that captured FTP files downloaded, started, successful, and failed. Then I created a dashboard. And now I know something about how good we do. Before that, there was just a feeling of being flaky. That's a great. I love having the real world examples. So in this case, we're doing metrics with Datadog to see trends about FTP downloads with Fuel Snable's example. Is that correct? Yeah?
Seems so.
Cool. Thanks for sharing, Fuel
Also,
Snable.
also you can use metrics to add like the context to the information or to your events. Like this context is what we talked about like previously, that, hey, I have an error, I can see like some errors, but what is the blast radius?
And then the way to collect metrics is to use a tool like Datadog? Or, yeah.
You can definitely use it. Datadog, as far as I know, has some tools. But if you are using Spring Boot, there is a project called Micrometer.
Okay.
And Micrometer is a library for the JVM. And it is the most popular metrics library on the JVM as of today, as far as I know. And it's like SLF4J, but it's for metrics. It has a simple API, and it supports the most popular metric backends, for example, Datadog. We have, I don't know, like around like 20 of them that is support, maybe more, like metrics backend that we are supporting. One of them, by the way, is like tons of observability.
Okay.
Micrometer supports that. Nice. And also, like people mentioned, like Prometheus and Grafana before. Micrometer supports Prometheus as well. So basically, you can use the Micrometer API, capture your data, and you can basically like ship this data into various backends. That's the whole idea behind Micrometer.
Cool. So you need a tool to collect metrics, is what I'm hearing. Micrometer is a great tool for Spring Boot and can integrate into a lot of these larger tools. And then, but if you're not doing Spring Boot, you might use Datadog or Tanzu Observability or Prometheus.
If you don't use Spring Boot, you can still use Micrometer if you want, because that's just a Java library. You can use it for everything. For example, Aaron is the maintainer of the Quarkus support for Micrometer, so you can use it for Quarkus as well. You can use it with any Java-based application. If you are on the JVM, I would recommend looking at Micrometer, but shameless plug, I am biased. I am one of the maintainers of Micrometer.
For JVM, so not just for Spring Boot. I guess I should do it here, right? Is that accurate? Metrics can add context collected with tools like Micrometer for the JVM or Datadog, Tanzu Observability, or Prometheus. So when people say monitoring, is monitoring the act of collecting metrics?
It is usually, yes. So monitoring is usually an active process that you are basically like trying to get some data that, hey, for example, a health check and monitoring the health state of the service is definitely monitoring. Like you are asking this question all the time that, hey, are you up? Are you up? Are you up? But it's it's like active, like you will always try to ask this question. The other thing is that you already know this question in advance. That's, I believe, maybe the most the biggest difference between observability and monitoring is that monitoring is about like known questions or known knowns or known unknowns. But observability should be about unknown unknowns. So you're basically measuring a lot of things, and at that point, you don't know what will be important later.
Got it. We have a lot of chat. There are 19 metrics backends listed on Micrometer.io. Thanks, Java.
We have some which are not listed there because like they are new, or we are not recommending them for production, but for debugging. But yeah, right now I believe we like 19+1, I would say, because we just added one last week. and we released it. And I believe it is not yet documented on our like docs page. We need to do that.
Backstage. FuelStable says a huge thing with metrics and logs is that I can put alarms on critical metrics. These alarms are sent to a notification Teams channel that allows us to react to things. And that probably goes back to your early point about you figuring out stuff before your customers do, which is awesome. Some monitors are tagged as really bad, and they trigger pager duty, which calls the on-call engineer. And we have a new chatter. Hello, welcome. AWS CloudWatch and EventBridge events. Also consider observability patterns. Thank you for the roadmap graphics. Yeah, you're welcome.
Okay, so let's move quickly to distributed tracing, because I am not worried about metrics at all at this point, because I believe this is the third time I'm mentioning it. Erin will cover everything, so she got like very, very high expectations now. I hope she's still there and listening.
All right. So, distributed tracing, not just tracing, but distributed tracing.
It is, so the difference between them is that, like, if you are tracing something that you are an event that you are doing something, what makes it distributed is because you should be able to trace those between applications. So it can be like between processes.
So not just between, okay. When I hear the word distributed, I think of Kubernetes or distributed between machines, but you're talking about distributed between applications.
Yeah, so in Kubernetes, like you are running like multiple pods, and those are like separate like applications usually who are talking to each other. So that's the distributed means in distributed tracing. Great.
And Erin says she's on it in terms of teaching us way more about metrics on June 16. FuelStable says another thing about metrics and logs, keep an eye on cost. At a previous place, we had a DD metric that cost $8,000 a month, and no one looked at it. What does DD stand for? I have guesses.
Datadog, I guess.
Oh, okay. And ready. So, and then FuelStable. I'm really enjoying your real life example, FuelStable. FuelStable managed once to generate 50 million log events per minute once. Wow. Luckily, I saw it and shut it down fast. The log aggregator, okay by that load, but the bill would have been huge.
Yep.
All right, distributed tracing. Wait. Give it to me, Joni.
So it's distributed tracing is basically, the problem here is that you want to track down or trace down events that are connected. And let's say that you have like multiple services, like you have like a service which calls like another service which calls a database. So the problem statement is, how can you track down what happened in your applications when your user calls the first service, that calls the second service, and that calls the database. So how can you identify these causal like events, like with causality, and how can you identify that they belong together? What should you do? So distributed tracing is usually doing this by propagating some information. And for example, when like this is called context propagation, we can like totally put it on the dashboard. Sorry, on the board. And what happens is basically when a request comes into the first service, it will attach a ID to it. And this is called trace ID in the distributed tracing systems.
Will you repeat the first part of that sentence? When what happens, an ID gets attached?
So I am just giving the example, so you don't really need to like capture this on the board.
Okay.
But when, for example, the user calls the first service, it will basically, what it will do, it will attach a ID to this event.
Okay.
And when service 1 does something that is caused by this request, it will tag all of those events with this ID. And when service 1 calls service 2, it will propagate this ID over the network. So service 2 will know that, hey, I am doing things because service 1 did something which was the result of the user calling, and all of these are chained or like attached to one single ID. So when this happens, and that's why it is like distributed and tracing, that all of these applications, they will know about that, hey, I am doing my thing, and that thing belongs to this bigger picture. And that is basically identified by the trace ID.
So when a service gets called, it attaches the ID, and then the ID follows every related call.
Yes, yes, and that is the trace ID. There is another thing which is important here. It is called the span ID. And
okay, so this is called a trace ID? And then what's the other one called?
Span ID.
Span ID?
Yes, SPAN ID. And the span that the span ID identifies, it is basically the basic unit of work. So
base unit of work.
So those are like these smaller events that happens in the applications. So basically the trace ID correlates these spans. All of those spans that belong together, they will have the same trace ID, but they will have the different span ID. So the trace ID is the correlation ID, big picture, span, these small pieces of the puzzle.
So in our example where a service gets called, it attaches to an ID, then the ID follows every related call. So each time our ID gets passed from one place to another, each of those is a span ID?
Yes, the span ID and the trace ID as well. Because in order to identify calls as well, you need to know who was the parent in the span. So when you have like one basic event, one span, and that will cause another span, this other span, the child, should know about the parent. And it will attach it. It will say that, hey, this is my ID. I happened because of this other span. And both of them will say that, hey, we both belong to the group of spans, to this trace. Exactly. It's a little bit better with some visualization, if I can put these. With some services, but that is the basic idea.
So
you have
these span IDs know how they relate to each other.
Yes,
that's what it. Is this enough space for distributed tracing?
I think so, because that is mostly all. I will tell you about like what Spring has to offer for distributed tracing, but yeah, that is the gist of it.
Okay. Before you dig in on Spring, I'm gonna catch up. Feel Stable has more tales from the trenches. JavaCrud says, I also enjoy hearing the real world perspectives in the chat. Thanks, everyone. Feel Stable says, getting services to agree on trace ID, correlation ID is surprisingly hard. The correlation ID allows you to search for logs for that logical operation. And don't add correlation ID as a Datadog metric tag. That's a good way to either get a huge bill or get shut down by Datadog. Time series DBs are not logging. Okay. There's a cost by adding unique combinations of tags. As you see, I have opinions on observability. You did promise up top that you did. By the way, you know you have succeeded with observability culture when you lose the observability service. They have outages like everyone else, and you feel really bad because you don't know what's going on. And that makes a lot of sense. If you miss it when it's gone, that means it's valuable.
Let me reflect just one of these because I am not capturing it, but Erin will. So the correlation ID added to metrics, and why is it bad? That is a very, very like common mistake, that people are attaching the data into metrics that they should not, because there are a few things you cannot do, but I'm not going to like spoil this part. Come to the next next session and you will learn about this.
So getting the service to agree, there are things you can do to make it less hard, but Aaron's going to talk about it on June 16th.
No, not that one. That one. Like
not
why you should not add, for example, a correlation ID to your method.
Oh, okay.
That's the
this one. Don't add a correlation ID as a metric tag. Got it. So we'll talk more about
services, yes. How can services run the same like correlation ID? I can basically use this to funnel the discussion into what Spring Boot has to offer.
Excellent.
Because we have like Spring Cloud Sleuth. Again, I am one of the like maintainers of Spring Cloud Sleuth. I am biased. Spring Cloud Sleuth is the distributing tracing solution for Spring. So if you are using Sleuth, then basically it will give you these features out of the box, and your services will agree on this correlation ID bi-naturally, because Spring Cloud Sleuth will give you the standard for them. And Sleuth is basically like, other than being the distributed tracing support for Spring, it basically does like two things. One is it gives you an API, it provides an abstraction layer on top of the tracing libraries. We have support for OpenZipKin's Brave and OpenTelemetry tracing as well. And it will give you all of these features that you need, like log correlation, context propagation. And also Spring projects are instrumented using Sleuth. So if you're using Spring Boot, then you will get instrumentation out of the box.
So with distributed tracing, you also need some sort of third-party tool to be able to capture this. Spring Cloud Sleuth is a great example. Datadog is like, yeah.
Sleuth is basically the component that you will add to your application, and it will capture this data. And Sleuth will send this data to a backend. And there are various backends that you can use. You can use, for example, like Tanzu Observability. You can use Datadog. You can use like OpenZipKin. There are many backends. Basically, if you see any solution labeled as the observability solution, which is like more marketing terms of today, they should support distributed tracing out of the box. And most probably, there is a very, very big chance that Sleuth will be able to use it. Support it, because Sleuth is supporting the most popular like tracing format on the wire that these systems can understand.
Excellent. So we have the so-called pillars of observability: logging, metrics, and distributed tracing.
And let's go to the fourth one. This is the most fun part. This is the one I like the most. But let's just like very quickly just run through them. Because we will not have time. One is health checks. So this is something I usually call like non-conventional observability. I'm not sure what is a good name for this. These are all of the other components that give you information, but cannot really fall into these categories of logging, metrics, or distributed tracing. And people are usually not doing this. That's why I usually call them.
Step up your game by using these tools, right?
Yes. So one is health checks, definitely. This is what was mentioned by Erin. This is very, very important. So being able, if your service is healthy or not, and if not, why, that's a very, very useful thing to have.
Excellent.
Another thing is, I'm not sure how to call it. Spring Boot calls these info contributors. basically boot has a endpoint called the info endpoint. And this info endpoint can give you some details about your application instance. And for example, like which version was deployed, what is the version of the application. If you have ever seen like the wrong version deployed to production, you might know why is this important. Or if you have seen the right version deployed to production, but the automation said, hey, there is a glitch, something happened, so I'm rolling back. But you did not get an alert about it, so you think that 1.1 is out, but it's not. It's 1.0. So that can be like very, very useful. Or you can say that, hey, 1.1 is out, but 1.1 was built against a feature branch, not a release branch, not against main, or it was built against the wrong commit. So the thing that tells you that, hey, I am 1.1 is not really the code that was built that's supposed to be 1.1. That can be very, very useful too.
So info contributors provides information like version, and did you say feature flags?
You can, so basically you can put anything that you want there. That's, I believe that is the that is why info endpoint is that so powerful.
So like
feature flag support, this doesn't really exist as of today, but you can put there any property. So if your feature flag is a Spring property, then yes, that is totally true.
So like versions, ports, environment variables, that sort of thing.
Yes. Yeah.
Cool.
I will mention a couple of more because like there are, for example, we added the Java info contributor in Spring Boot 2.6, which tells you what version of Java are you using.
Okay.
And people are usually asking this question, okay, like why is it important? I know what version of Java am I using. Trust me, not necessarily. I totally have been in this situation when this was like 12 years ago. The Java versions was like in a folder maintained by ops, and we basically upgraded our Java version like from 6 update something to update something +1. And what happened is that we were on Java 5 instead of 6 because somebody put like Java 5 into a folder named Java 6 update something. Also, if you are using Docker, you might need to know that Docker is caching the images. So if you are depending on latest, that might not be the latest. It will be the latest if you tell Docker that, hey, upgrade your caches. So the Java version can be like very, very important there as well. Also,
Feel Stable says that alarm should be part of non-conventional observability, maybe?
You can, I can definitely see that. So, and actually I implemented this. So I had a set of like deployment checks in the past, which basically run after the service was deployed. And what these deployment checks did is basically like checked if the service is healthy, but they also checked a couple of other things that, hey, this is the version I wanted to deploy. This is the environment I wanted to be in, because like deploying into production with like staging settings, it's not necessarily good. It also checked like a couple of other things about the service.
Joni, we only have 5 minutes left because we have Nate's show coming on between chair and keyboard. Yep. Okay.
Let me then just talk one more thing. I guess like other than these info stuff, which is like service discoverability.
Ooh, I like that one.
And what this basically does is try to answer the questions of like how many service instances do we have, what versions are deployed, by what in what environments, where they are, port IP, like which instance, which region, what cloud provider, when did they start and stop. So you will have this sense of services. And I basically
Okay.
like have a cool story about this, and let's wrap up with that. I
Okay.
basically added a like service discoverability or service registry functionality to a couple of services I built years ago. And I had a TV screen next to my desk in the office, and I saw all of our services with the versions as well. Kubernetes is kind of doing that as of today, so you might necessarily need this, but if you are not using Kubernetes or you want more data, you might want utilize something like Eureka, which is a service registry or something. So I had all of those services on the dashboard, and those services was transferred to another team, and they did not like this functionality. Mostly because when the service started, it was like very chatty about this.
Okay.
And in their local environment, sometimes it wasn't able to connect to the registry, so it was just warning like errors out, which did no harm. The service was able to start, but eventually, fast forward, they removed this. So the services disappeared. And after they removed it, I believe a year later or more, at least one service just popped in again. And just went to them that, hey, like you now you like it, like you put it back, and they said no, we did not. So what happened? Somewhere out of the blue, a version of this service which still did have this functionality, so it was like at least 1 year or more years old, just started somewhere. And it like did its thing, like it processed the data and like with the wrong feature set. So yeah, service discoverability and registry can be very useful.
And so is that how you found it? Because you had some sort of service discoverability in your system?
It was there. It should not with a very old version.
Okay.
So you basically just get a quick like look through about, hey, these are the services that are currently running and these are the versions. You can look at them and you can say that, hey, this is not the version that should run into production. Or, hey, this service is not up. Or, hey, this is up, but it should not be because we decommission it. So it can answer these questions easily.
So we have 40 seconds. I'm going to say goodbye, but I would love to know very quickly an example of, are there tools out there like health checks? I'm seeing in the chat Spring actuators handle health checks.
Yes.
Where would you get?
Gives you the health check, the info stuff, what I mentioned. And if you want like service registry, we have support for that as well. So if you look into the Spring Cloud projects, they will give you this, usually by using like Eureka or Console. So Eureka is for Netflix.
Discoverability is Eureka?
Yes.
Cool.
Yes. Eureka is the registry. Discoverability is basically using the registry and being able to discover them.
Cool. Thank you so much, everyone. Have a wonderful day. Sorry to end so suddenly. Thank you, Joni, for coming on, and thank you, everyone who watches this later. Stay tuned for Nate's show. Bye.